Today is April 25th, and we're going to start with right triangle trigonometry and continue on with what we started to build in this unit. So I'm going to start off with reminding us, how do we simplify a square root function? If you do not know perfect squares, please write them down. I'm going to put it right above here. 1 squared, this is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and 7 squared, 8 squared, 9 squared, 10 squared, 11, and 12. And does it stop right here? No, but for the purpose of doing 3 to 5 problems, I think that's as far as we need to go. Now, when I rewrite this in simplified form, it's still going to be equivalent to the original expression. It's just simplified. So we're going to grab a calculator right now. And we always want to try to find the largest perfect square that divides into this. If we can't find one, then we can't simplify it. It may be right now in the simplest form. Let's try this. Okay, ready? I'm going to start with 208. And I'm going to divide it by each of these perfect squares. So I'm going to just keep winding down here. I know that I found a selected one when the answer that I receive, or the outcome I received after dividing by a perfect square, is a nice, pretty whole number. So I have 208 divided by 100, nope. 208 divided by 81, that's not working. And you can see I'm just working my way down. Divided by 64, no. Divided by 49, keep going. Divided by 36, I'm just going to keep working myself down here. 208 divided by 25, 208 divided by 16. Oh, there we go. I finally was able to find a perfect square that divided nicely into the provided value underneath the square root, and the result was a whole number. So I'm going to take the perfect square, which is on this list, and I'm going to break this into the square root of 16 times the square root of 13. Square root of 16 times the square root of 13 is the square root of 208. Now, I know the square root of 16 is 4, because 4 times 4 is 16. This is in reduced form. I want to illustrate to you that the square root of 208 is equivalent to 4 times the square root of 13. They're the exact same value, but is in simplified form. Grab your calculator, and you are going to race me here. You're going to race me. We are doing this one together. So I'm at 396. We want to choose the largest perfect square that nicely divides into this. We're working ourselves all the way back down here. 396, 144, 121. Oh. If you look up here, 36 is the first one that works. I want you to rewrite this. What does this look like? I'm going to place the perfect square first. So square root of 36 times the square root of 11 is equal to the square root of 396. I know the square root of 36 is 6 times 6, so the square root of 36 is 6. This is equivalent to this original portion. Let's go on to our next one. I know right away I have zeros on the back, so if I divide this by 100, I get a nice outcome of 13. The square root of 100 is 10. 10 times 10 is 100. Ow! I'm going to race you, and you have a 30-second head start. It's not going to be a hard one. If I see a cell phone, you don't have to take a quiz later on. You have a 0. Make sure all cell phones are put away. This is the expression I want you to simplify. Ready, get set, begin. So one part of confusion is some students may start by taking 26 and dividing it by really large numbers here. 26 is between 25 and 36. I don't need to try any of these numbers. So I'm going to put my calculator in front of that. 26 divided by 25, not a whole number. Divided by 16, not a whole number. Divided by 9, and divided by 4. So it doesn't reduce. Now, some students may say, but can't you divide it by 1? Look, I get a nice answer. But if you come down here and you divide it by 1, don't talk when I'm talking. The square root of 1 is 1. Does that help me do anything? It didn't help me break it down at all. So if 1 is the only number that helps you reduce something, you really can't reduce it. This is in simplified form. Now let's take this concept and let's try it in fractional form. So let's start by writing down 3 over, and let's go with the square root of 20. We get an answer. We have 3 over the square root of 20. And mathematically, I'm like, this is right, but it's not in the correct simplified form. So what I'm going to do is I'm going to start by doing the following. I want to first see, is it possible for me to write this in a better form? So forget about it being as a fraction. I'm going to start and going, okay, here's where the square root of 20 is, right there, square root of 20. I'm going to divide it by 16, 9, and 4 and see if any one of those values divided nicely. Divided by 16, no. Divided by 9, no. Divided by 4, hey, that works. So I'm going to break this into 3 over square root of 4 times the square root of 5. Now I know the square root of 4 is 2. So I have 3 over 2 square roots of 5. Before I go any further, I want to stop for a second. Can I have a thumbs up or a thumbs down if you're understanding what I've done so far? Okay, all of this is beautiful, but there's a problem. I still have a square root on the bottom. So what do I do in this situation? I'm going to take whatever needs to be removed. I want to keep the same value, and I'm going to multiply it times the bottom and the top. When you take the exact same value times the bottom and the top, it doesn't change the value over here. The original value remains the same. So now I have 3 square roots of 5. They can't be combined. It's not like the square root of 15 because they're not both in a square root form. Now on the bottom I have 2 times, these are both square roots, so 5 times 5 is 25. The square root of 25 is 5. I'm going to be lazy. The square root of 25 is 5. Now I have 3 square roots of 5. 2 times 5 is 10. And most of you are pretty good at simplifying. By the way, these are in the exact same form, so it's possible that I can simplify them. How do I do that? If you grab your calculator, locate what's blue and says alpha, and I'm going to go directly to the right. And if you're not great at simplifying, you can hit the alpha key in green and then go directly to the right. I'm going to write 3 over 10, not the square root of 5. It's not like terms. If you press enter and it does not change a fraction, it means it's in simplified form, and this is my simplified answer. This is equivalent to this original portion, and I want to demonstrate that. 3 square roots of 5 divided by 10. Okay, this is equivalent to 0.67. If I come up here and I divide, it's also going to be equivalent to 0.67. They are equivalent values. How do I know if 7 over 6, the like terms, if they're in simplified form? If you're not good, you're going to hit the alpha and to the right, and I'm going to do 7 over 6. And if we get the exact same fraction, we know it's in simplified form. This is equivalent to this original. I'm provided with a triangle, and I can see 2 of the 3 sides of this right triangle. And I want to provide the sine, cosine, and tangent. Remember, those are primary trig functions, and all they are is we're going to do, in order, we're going to describe 2 of the 3 sides to come up with the sine, the cosine, and the tangent. Now, those 2 sides, here we go. Oscar had a heap of apples. The order that we choose 2 of the 3 sides matters. So for sine, we want to identify from this angle what's opposite over the hypotenuse. Well, I'm missing that opposite side, so I'm going to use the Pythagorean theorem. I need to see your work to understand that you get how to do this. Now, some steps I'm going to do on my calculator. Of course I am. So A can be and B can be 10. Doesn't matter which one it is. I'm going to make A 10. I don't know the other leg, but I know the hypotenuse is 26. Now I can isolate b squared by taking 26 squared and subtracting 10 squared. I'm going to grab my calculator and I'm going to go 26 squared minus 10 squared. Notice how I wrote it down here? So if I was a student, I could show my teacher that I understand the steps. When we take the square root, it says there should be two answers, but remember, we are describing the length of a triangle, and length is always positive. Now I'm going to take the square root of 576, and I get an answer of 24. B is 24. I come up here and write 24. When I come up with the sine, the cosine, and the tangent, I want to make sure that my answer is in simplified form. So here we go. Here is my angle. Sine is opposite. So I'm going to write it down over here. Opposite over hypotenuse. That is not wrong, but is it in simplified form? Well, if you come up top and hit the green button and directly to the right, and if you're not great with simplifying in your head, we can see that it simplifies to 12 over 13. That is the sine, the ratio. Okay, Manny, please tell me how to do the cosine. Cosine of this angle. How did you choose 10? You're right. How did you choose it? Adjacent. Remember, adjacent helps create the angle, but it can never be the longest side or the hypotenuse. And then again, maybe for some of you, you feel more comfortable simplifying on a calculator. We can see this simplifies to 5 over 13. Finally, tangent is going to be opposite over adjacent. 24 over 10. Again, you're going to plug into your calculator and you get 12 over 5. Okay, so just like the last problem, first I need to figure out the missing side before I can do anything more. So I'm going to come over here and do the Pythagorean theorem. A squared plus b squared equals c squared. And I can isolate the b squared by subtracting 15 squared to the opposite side. I've shown all of my work, which I expect you to do as well. And now I can use the calculator in order to combine 75 squared minus 15 squared. All right, I get 5,400. Oh my goodness, it's a really large number, 5,400. I take the square root of it, and here's the problem. I don't want you to give me an estimation. I want an exact answer. When I take the square root of 5,400, notice that I get a decimal answer. Don't give me decimal. That means I need to come back here, and we're going to practice what we did at the very beginning of today's lesson, or the video if you're watching this. So I need to think right now about perfect squares. So grab your calculator. Let's start with what we knew. Let's start with 144. No, that didn't work. And let's try 121. That didn't work. And let's try 100. So I'm going down the perfect squares, and I could have gone even higher. Oh, 100 works. This breaks into 100 times the square root of 54. Well, I know the square root of 100 is 10. But now I have to ask myself, the square root of 54, can that be broken down further? So I want you to look back to that paper that listed the perfect squares. That would be right here. And we can see 54 would be right between 49 and 64. Do me a favor. Please take 54 divided by 49. Divided by 36. 25, 16, 9, and 4. And see if any of those are able to reduce the square root of 54. Did I hear somebody say that 9 works? Is that correct? And if you have strong multiplication skills, that already probably would have popped into your head. And we can see 9 works, so let's break it down. This breaks down to the square root of 9 and the square root of 6. Now, is it necessary for us to do this? Yeah, it's necessary. The square root of 9, I'm going to be lazy, is 3. So I have 10 times 3 times the square root of 6. So B is equal to 10 times 3 is 30. This is what B equals. 30 square roots of 6. Let's get started with the sine. Christian, can you give me a ratio? It does not have to be in simplified form. Can you give me the ratio that describes the sine of this angle? 15 over 75. He chose the opposite over the hypotenuse. Now grab your calculator, please. We want to put this in simplified form. We can hit the green button directly to the right of it. I'm going to go 15 over 75. Beautiful. Oh, it reduces to 1/5. 1 over 5. That is my reduced answer for the sine of theta. Okay. Help me out, Joseph. What is the cosine? What is the ratio? Okay, now this is where it gets tricky. We see three different numbers, 30 square root of 6 and 75. These are like terms, so grab your calculator, and we're only going to plug in the like terms when we're asking ourselves, can this fraction be simplified? Don't put in the square root of 6, just 30 over 75. We can see it does reduce to 2 over 5, so this is 2 over 5, and then on top is the square root of 6. Can I have a thumbs up or a thumbs down if you understand that? Okay, now this is where it's going to get tricky. I do want to say that in the past, students would say, Miss Bradley, there's a problem here. You have a square root. You can have square roots in your final answer that are in the numerator, but you can't leave them in the denominator as the final answer. Louise, can you help me? What is the ratio? Not simplified, just the ratio that describes the tangent of this angle. Perfect. Grab your calculator. Let's forget right now. I'm going to cover this up. Let's forget this was even here. Simplify for me 15 over 30. Simplify 15 over 30, and 15 over 30, if you can't do it in your head, and I just plugged that in wrong, should be 1/2, and I'm demonstrating how to do it on a calculator if you struggled with that. We can see it's 1/2, not 2, but 1/2. So I'm going to write this as 1/2 with the square root of 6 in the bottom. None of that is wrong. But what is the problem with this being my final answer? Juan, what is the problem with this being my final answer? So whatever this is, I'm going to rewrite it by taking the top and the bottom times the square root of 6. So I have 1 times the square root of 6 over 2 times the square root of 36, because 6 times 6 is 36. I know that the square root of 36 is actually 6. So on top, you can write 1 times the square root of 6, or just the square root of 6, because 1 times itself is itself. And then on the bottom, I have 2 times 6 is 12. This is going to be the tangent of that value.